All right, so we're jumping back a few sections. We have to go through two sections in chapter 5, one on the Pythagorean theorem and another one on special right triangles. The one on the Pythagorean theorem, I'm going to go through pretty quickly because this is something that you've seen before. Number 2 is something that might look a little bit different, and there's some stuff on this page that you haven't really seen before. So I'm just going through one because it's a little bit harder of an algebra example. I know that you can do a squared plus b squared equals c squared. I just want to make sure that you can do it with a question like this. So if I went to go do this one, I would have to go a squared plus b squared equals c squared. Now don't try and distribute that 2 down to the x and the 1. You're going to have to FOIL this out. So remember from your Algebra 1 class that that's something that you're going to have to make sure that you do out. So make sure you pay attention to that step. Once I do that, I can FOIL, and I get 25 plus x squared minus x plus 1 equals x squared. If you add that together, 25 plus x squared minus 2x plus 1 equals x squared. You notice that you have an x squareds on both sides of the equation. That can go away now. So then you have 25 minus 2x plus 1 equals 0. From there, I can move the 2x to the other side, and I get 26 equals 2x, and that means x equals 13. So that's how you do something like that. If I went too fast there, you can try and go back and check it out and see what I did. Just make sure that you're very clear on this foiling step. Just want to make sure that that makes sense. For 2, it says to prevent a ladder from shifting, safety experts recommend that the ratio A to B be 4 to 1, so that the height be 4 times as long as the width, if you look at the picture. It says, how far from the base of the wall should you place the foot of a 10-foot ladder round to the nearest inch? So this is sort of similar to the ratio questions where I gave you the ratio of a few angles in a triangle, and you had to find what the lengths were. So you start with an equation that you know. And then you substitute the ratio stuff into that equation. So the height, which is A, needs to be 4 times as big as the length, which is B. And that should equal C squared. Now, it says that this is a 10-foot ladder. So I should be able to take the C and replace it with 10. And I should be able to solve that from there. Now, on this one, you do have to distribute the 2 because this is 2 things that are multiplied together. They're not added together. So that's different than foiling. So this is 16x squared plus x squared equals 100, which means 17x squared equals 100. If I take this equation and keep going over here, I have to divide by 17. And then I have to take the square root of that. So x equals the square root of whatever 100 over 17 is. So I go to my calculator and figure that out. So 100 divided by 17, and then I have to take the square root of that, which is, where is it on here? It's the y root. Am I not? Well, it's probably this one. No, that's the y, so square root. All right, so I did it on this one. I must have, I don't know where the regular square root part is. But anyways, I did it. So 2.43, you're probably going to be using a scientific calculator or something, so you'll know how to do that. So 2.43. Now, this is in feet, so I got to take that 0.43 and multiply that by 12. So this is going to be 2 feet, and then I'm going to take 0.43. It's 0.43 times 12, which is about 5. So it's 2 feet, 5 inches. So that's how you get that. If I confused you with the square root part in the calculator, I'm sure you know how to do that on your own calculator. So, all right, so that's that. Those are a couple of Pythagorean theorem questions. This is another way that you can apply the Pythagorean theorem. So part of this question is from earlier in chapter 5, so you're not going to really be able to do this right now. I don't think you have to know how to do this at this point. But it says classify it by acute, obtuse, or right. So I've given you some examples up here that show ways that you can do that. So if the hypotenuse here, if you look at C, is bigger than a squared and b squared, when you go to throw that into the Pythagorean theorem, it means that it's an obtuse triangle. If you look at the triangle on the right and this c squared is less than those other two added together, then you know it's going to be an acute triangle. And then you ask what happens if they're equal. Well, if c squared equals a squared plus b squared, it's a right triangle. So you've got ways that you can test that to see what kind of triangle it is, even if you don't, have a ruler and you can't draw it to scale or something like that. So now C is always the longest side, so make sure you note that, so that way you can answer these questions. So on this one, 16 is my longest side, so I'll test this. 7 squared plus 12 squared, and then 16 squared. So I don't know, is it equal, is it greater than, is it less than? We're going to test that out. So I've got 49 plus 144 equals 16 squared, which is 2 something. I don't know my 16 times tables. 16 times 16, 256. 144 and 49 is 180, 190 something, 193. And I shouldn't have put an equal sign up here, so I want to know if it's what the relationship is with 256. Well, 256 is bigger than that. So based on my examples up here, I should be able to say that's an obtuse triangle because this is larger. So that's an obtuse triangle. All right, let's test that again with this. Now this one you're not going to be able to just do off the top of your head. You're probably going to have to throw this thing in a calculator. So 3.8 squared plus 4.1 squared and then 5.2 squared. What's the relationship? If I go back to my calculator, I'm just covering that now, so, and I do 3.8 squared, that's 14.44. And then I have to add that to 4.1 squared. So together they're going to be, so that's 16.81. And if I add those together, I get 31.25. So I need to see what the relationship is between that and 5.2 squared, which is 27.04. You see pretty quick that that one's going to be smaller. And so since a squared and b squared are larger than c squared, that's going to be an acute triangle. That's pretty much all you got to know from 5.7. Little Pythagorean theorem stuff. I did a couple tougher examples because you can do the easy ones already. And then this part here, seeing what kind of triangles are which. So that's that. I'm going to move on to 5.8. So if you need to go back to any 5.7 stuff or you want to, go try any examples again, you can do that. I'm going to go straight on to this. So this is an application of similar triangles. So it just happens to come earlier in the book, but since you've done chapter 7, this should be easier for you. So I want you to ignore the bottom for a second, so don't worry about these examples down here. I want you to just focus on this triangle that's right here. So we're going to show ratios that are true in these right triangles no matter what the side lengths are. So really what your focus is we took a square and we cut it in half, right down the middle. That's how we know that these two x's are going to be the same. So I've got an x here and an x here and a y on that side. So we want to look at what the relationship is. And so I'm going to try and solve. I just dropped the mic, so hopefully it didn't sound too loud. Sorry about that. But we're going to see what the relationship is between those two x's and that y. So I'm going to set up Pythagorean theorem. I'm going to solve. So I've got x squared plus x squared equals y squared, which means 2x squared equals y squared. And when I solve for that and take the square root of y, this happens. So I've got the square root of 2 and the square root of x squared, which the x squared, I should be able to take an x out. So I'm going to take that and put it on the outside. So I've got x squared of 2 equals y. If this whole simplifying square roots thing is tough for you, you might want to go Google simplifying square roots and find some examples of that, because that's an algebra skill that I'm going to expect that you know how to do. So anyways, you can see that no matter what, in a 45, 45, 90 triangle, because all 45, 45, 90 triangles are similar, it looks like that the hypotenuse, which is y, is going to equal the side, which is x, times the square root of 2, which is the square root of 2. So no matter what, I mean, any 45, 45, 90 triangle should be similar. So this is a relationship that comes up in trigonometry a lot. I know that seems kind of random that we're just doing it here, but that's why we're showing why it's true. So a lot of times you'll see the 45, 45, 90 triangle written like it is in green right there. Another way that you could see it written is if you have a 45, 45, 90. By marking these two angles congruent, I'm showing that they're the same, and if one of the angles is 90, the other two should be 45. So that's how I know. Instead of x squared to 2, like I just wrote on the other triangle, a lot of places you'll see, and kind of the one that I typically refer to, is 1 squared to 2. I think it makes it a little bit easier sometimes. So you can use that relationship to solve some examples with ratios in any type of 45, 45, 90 triangle. So like if you look at 1a down here, and you want to find the value of x in this triangle, well, I've got one of the sides, and I want to know what this is. Now, over here, if you looked at the examples that we did over here, if I have a side and I want to find the hypotenuse, I should be able to take the side and just multiply it by the square root of 2. So if I take that side, 10 squared to 2, so that's the side. If you look at my relationship up there, so I've got a side, I should be able to multiply that by the square root of 2, and I should be able to get the hypotenuse. So if I just rewrite that same equation, 10 root 2 times the square root of 2, that should give me the hypotenuse. Well, 10 square roots of 2 times 10 square roots of 2 is 10 square roots of 4, which is 10 times 2, which is 20. So that's where that answer comes from. So you could also have done that in a different way. I'll show you underneath. If this makes more sense to you, then you can do it this way. If you've got a 45, 45, 90 triangle, like the one that's up there, so you've got one that's 10 root 2, and you want to know what this is, just set up the other base one that I had showed you up there that has 1 in the square root of 2. I mean, if it's a 45, 45, 90, they should be similar. You know how to do this stuff already because we've been doing this for the last few weeks. If I set up a little proportion, 10 root 2 over 1 equals x over root 2, you end up with the same thing because when you solve this, you get x equals 10 root 2 times root 2, which I just showed you already simplifies down to 20. Now, if that makes more sense to you, if this example down here makes a little bit more sense, then go for it. Do it that way. All right, so let's do this second example here, and then I've got one other type of triangle to show you. All right, so again, I could use this green equation that I set up over here. I should be able to take this same thing and use it to solve this equation. If you have a side and you multiply it by the square root of 2, you should get the hypotenuse in a 45, 45, 90 triangle. So I've got a side, which is x. I've got the square root of 2, which is just the square root of 2, and that should equal the hypotenuse, which is 16. That's easy enough to solve. You just divide that by the square root of 2. So you get x equals 16 over the square root of 2. Now, one thing that you may remember from algebra is that you're not supposed to leave this. So while this is a correct answer, you're not supposed to have a square root in the denominator. So if you remember, we need to rationalize the denominator. So I'm going to do that. I'll multiply by root 2, and I get 16 root 2 over square root of 2 times the square root of 2 is 4, which means I get 4 square roots of 2. So that's the answer that you're going to be looking for. That's the answer that you would see in a multiple choice question on a test. or something like that. So just wanted to make sure that you knew how to do it that way. I'm an idiot. So 2 times 2 is the square root of 4, which is 2. So you get 16 over 2, and that's 10 to the square root of 2. So this should actually be an 8. So, my bad. All right. So let's go from there. Let's move on. If you need to go back and watch this again, I mean, this is tough stuff. It's not, all that easy sometimes. We're going to do another day of practice on this stuff, and these are just some of the basic questions. So there's one other type of triangle that becomes important, and that's a 30, 60, 90 triangle. A 30, 60, 90 triangle gets created when you take an equilateral triangle and you cut it in half. So you know that this length is going to be twice as much as this, because if you add the whole bottom segment, PR, together, you would get 2x, and so all 3 sides are 2x. But if you split it in half, and you get a 30, 60, 90 triangle, which is what we tend to call this, so we call it a 30, 60, 90 triangle. So you tend to call the other one also a 45, 45, 90. I didn't really mention that up here, but I mean, if you wanted to go back, that's kind of the title of what's going on. So a 30, 60, 90 triangle is going to be one, obviously, that has angles of 30, 60, and 90 degrees. So again, we've got these 2 sides in terms of x. I would like to get the last side in terms of x as well. So the triangle that we're looking at here, if I just rewrote it, and maybe I'll do it in blue so that you can see the same exact triangle. So that's y, that's 2x, and that's x. So if I wanted to solve for y, I could substitute this into the Pythagorean theorem again. I mean, I should be able to say that x squared plus 2x squared equals y squared. If I've got one of the sides in terms of x, I want all the sides in terms of x. So that's why I'm doing this. So I get x squared plus 4x squared. Oop, if you noticed, I've set up my Pythagorean theorem wrong. I didn't use my hypotenuse as the longest side. So what I should have done is taken this and made it the longest side, and y should be over on this side of the equation. So I'm going to set that up again and show you exactly what I'm talking about. Again, these are my a and my b as far as the Pythagorean theorem goes, and the 2x is going to be my c. So I need to make sure that I put that on the other side of the equation. So I should have x squared plus y squared equals 2x squared. If that whole change didn't make sense, just rewind 30 seconds and watch it again. So anyways, I've got x squared plus y squared equals 4x squared. If I subtract x squared, I get y squared equals 3x squared. And then similar to the last question, on the last step, if you take the square root of this, you can see that y should be equal to the square root of 3 times x. So an equation that you can set up from this, let's split this up. Come on. No, not going to get split. All right, so an equation that you can set up from this, if you've got this last part, y equals, and I'll write it like this because it's a little bit clearer. So you can say that y, which is the longer side, should be equal to the shorter side, which is x, times the square root of 3. So that's where that's just a way to write out the equation in words. Some people find that helpful. So the longer side equals the shorter side times the square root of 3. The easy one is the hypotenuse is just 2 times the short side. Or you could say that the short side equals the hypotenuse divided by 2. So you got some options here as far as what you want to call this stuff. By far, the one that's most annoying to know is this one. I promise you it does come in useful. It does become useful. So I've got 4 examples down here. I'm going to do them because these are a little bit tricky. So I know that we're up to 20 minutes, but I'm going to show these examples because I think this is something that you're going to be able to refer back to. So it says find the values of x and y and give your answers in the simplest radical form. So I'm going to go through each one. I'll try and explain as much as I can, and then we'll be done. So actually, let's scroll up a little bit so that you can see at least a little bit of what this stuff is. So anyways, this first one here, we've got two things that we want to find. Now we're being given the hypotenuse, and so I go look up top, and I see automatically that the hypotenuse was 2 times the shorter side. Hypotenuse is 2 times the short side. So I look at that, the hypotenuse, which is 18 root 3, should equal 2 times the short side, which is x. If I just divide that by 2, I get x equals 9 root 3. All right, so that's 9 root 3. The other thing that I know is that the longer side equals the shorter side times the square root of 3. So the long side equals the short times the square root of 3, based on this equation that I already solved. So long side, which is y, equals the short side, which is, we've already found to be 9 square root of 3, times the square root of 3, which means y is 9 times the square root of 9, which is 9 times 3, which is 27. So y is 27 and x is 9 root 3. Oops, someone's at the door. Hold on. All right, so let's do these last three. So again, I would refer back up to here. If your book isn't going to write out these equations like this, they're not going to show you this. I just find it useful at the beginning to write them out because I think it tends to be a little bit useful. If you want, I'll show you a different way to solve this. So I said before that we know that we can use similar triangles. So we've already proven that in a 30, 60, 90 triangle, the 30 being the smallest one, that whatever the short side is, the hypotenuse is 2 times that. And this side, which is the longer side, just the one that's not the hypotenuse, is x times the square root of 3. So you could set up a proportion and solve using these examples that we have here. So if I wanted to solve for, say, for y, I could set up a proportion using the 24. So I should be able to say 24 over 2x, which these two correspond, equals y over x root 3. And I should be able to solve for it. Now you may be thinking the x's are there and you get two variables, but once you do it, y times 2x equals 24 times x root 3. The x's are going to cancel out. So you get 2y equals 24 root 3, and you just divide it by 2. You get y equals 12 root 3. So it's not as bad as it maybe looks to be at the beginning. Now the short side, you could do another proportion for this, but this one's kind of easy because the hypotenuse is just 2 times the short side, so that short side should be 12. All right, I'm going to do these last two, just in any method that seems to make sense. So on this one, the short side I've been given. If you're given that short side, then you're good to go because the hypotenuse is just going to be 2 times the short side. So that's just going to be 10. I know that this is the hypotenuse because it's across from the right angle. And I know that the long side equals the short times root 3. So this one should be 5 times root 3 because the short side is 5, you multiply it by root 3, and that should equal the long side, which in this case is x. All right, last question. So down here again, I'm given the longer side. So I don't know what the easiest way to do this is, but let's go get the short side, I guess. So the long equals a short times root 3, which means 9 equals the short side, which is y times root 3. If I just divide that by root 3, I get y equals 9 over the square root of 3. Now again, I have to rationalize the denominator. So just to remind you, I have to multiply this by the square root of 3 and this by the square root of 3, which is 9 root 3 over the square root of 9, which is 9 root 3 over 3, which is 3 square roots of 3. So that's 3 square roots of 3. Good part is the hypotenuse is real easy to get because once you get the short side, the hypotenuse is just 2 times the short. which is 2 times 3 root 3, which is 6 root 3. And that was the other one. I know these take a while, or that they're a little bit tricky, so it's going to take some practice, which is why I thought it was important to make sure there was a lot in here. You might have to watch this again. It's why we have 2 days for this stuff, or at least watch part of it again. So you can try it out and let me know what you think.